So in this lecture, I want to look at the general reactions of carbonyls and some things to think about. This will just be a brief summary of the types of reactions that carbonyls undergo, and then we'll look at the specific reactions in the upcoming lectures. Really, the majority of the upcoming lectures will kind of bridge off of this one lecture. Okay, so without further ado, here we go. So reactions of carbonyls, and these are sort of a general summary. Okay, so to start, what we want to do is we want to take the carbonyl, just the carbonyl, the CO double bond, and then we want to consider a resonance structure because it's this resonance structure that really gives us an idea as to what is happening and why things are happening with the carbonyl. What we're going to do is consider the charge-separated resonance structure where we put the negative charge in the more electronegative oxygen atom. Now, this is not as good as the original structure because now the carbon doesn't have an octet and we've introduced charge separation. But if we have to introduce charge separation, we're putting it on the oxygen atom, which is the way to go. Okay, so it's this resonance structure that really lays the groundwork for all of the reactions that we're going to study of carbonyls. So the first reaction I want to look at is the addition of a nucleophile. So a general reaction of a nucleophile is going to occur at that positively charged carbon atom, and we're going to see a carbon nucleophile bond being formed. Okay, this is where we're going to start. After this, we're going to move into what's called enolate chemistry. Now, enolate chemistry requires that we actually have a carbon atom next door with some hydrogen atoms. Okay, so what we're doing here is we're allowing a base to react, and the base is going to attack a hydrogen atom attached to a carbon atom and push electrons over to make a carbon-carbon double bond. This is called an enolate. Now, the reason why this reaction occurs is because of the positive charge character of the carbonyl carbon, which is shown in that resonance structure I have front and center. So this is enolate chemistry. We're going to be looking at that after we look at nucleophile addition chemistry. Now, in another variant of carbonyl chemistry, we're going to consider what happens if the carbonyl has an alkene attached to it. And again, we want to start with that resonance structure where we have charge separation. And here we're going to have an alkene present. And that alkene present could actually shift over. We just have sort of an allylic carbocation, which puts a positive charge really far away now from that negative charge, and it's there that a nucleophile can add. If the nucleophile adds at that position, we get a new type of molecule where we have still an oxygen with a negative charge. And the nucleophile is added, and actually if you look at that structure, it sort of looks like that enolate that I have drawn. So again, it's just kind of introducing a double bond. And then we'll finish with a carbonyl that has some sort of non-carbon or non-hydrogen atom attached to it. This would be a carboxylic acid derivative. This will be down the road a little bit, but the idea is still the same. We have a positive charge on a carbon atom, and then what we could do is chemistry on this to make carboxylic acid derivatives. So I'll just call it carbox acid derivatives for now. Sorry to be so abbreviated in there. Okay, so it's these types of chemistry that we're going to look at really, through the majority of the rest of the course, because it's this type of chemistry that really sort of underpins a lot of the reactivity that we see in modern organic chemistry. Okay, so this is a brief summary. You could come back here or reference this lecture as you're studying just to try to recall, hey, where are we at here? We're studying enolates. Okay, that's the general idea if you're having trouble grasping some of this. Okay, otherwise, we'll pick up with specific chemistry in the next lecture. So until then, see you next time.